Hello, everyone. I'm Evgeny, co-founder of Fluence. Thanks, everyone, for coming. I'm gonna speak a little bit about what we do at Fluence, and we do decentralized computing. Um, so this is like pretty obvious introduction. You know, if you here for the Web3 week, you probably believe in Web3 and decentralization. So in general, we kind of see the movement from personal computers to clouds and like to decentralized platforms in general for a lot of different tasks. And we sort of like succeeding in terms of decentralizing the financial system with all the blockchain stuff and crypto and smart contracts. And we are like, halfway there with decentralizing internet infrastructure, with storage, with like IPFS, Filecoin, RVF, and other guys. We see a lot of projects semi-successful around identity, and you know, and I just wanted to talk specifically about what happens around computing and how we see like the future of decentralized computing. So basically, I think of computing like a blockchain is a big part of this industry because that's the new way of doing computations. It's a like very expensive, very constrained way of doing computations, but they were created for a specific purpose of reinventing money and like financial instruments. That's why they have this very specific design of having consensus and having all the nodes in the network keeping the same state and exchanging the data and having consensus for every new transaction, state transition. So that this make them expensive, but like good fit for financial use cases. There also were several attempts in terms of like trying to do some general purpose, more like traditional computing, but decentralized. But they were mostly focused on batch tasks, like on heavy computations, on like a massive computing tasks, like for rendering a video, like or scientific computation, stuff like that. And we were trying to understand like if it's possible to find some solution that would allow us to avoid using traditional clouds like Amazon, Google, like at all. So whenever we build any application, or web application or mobile application, like something that our basically internet consists of, can we not rely on proprietary and centralized infrastructure at all in terms of software and in terms of hardware as well? And the point that that's a long concern for people who ever build anything in Web 2, that you usually want to build you want to create some new application, some new business as fast as possible. Then that's why you want to rely on some tools that provided by other companies and built by other people, especially in the form of APIs. But then when you use these APIs, you're basically locked in into proprietary databases, like proprietary companies that own these databases that provide API. And then like they control the access of yours to their API. And then if they don't like you anymore, they can just cut the access at any moment. And your application just stops working, and you have really no control over it. This happened to Twitter, it happened to Facebook, and a lot of such cases in Web2 space. And also like on the infrastructure level, you don't want to be locked in into a particular cloud provider. And there's a lot of stories that like even if people were happy with some cloud provider, were happy with the pricing, with the tooling, but when their business starts growing, the pricing may not be good enough, but they already created so much things on the proprietary stack, so it's too expensive to switch. So people paying like Amazon a lot of money, especially when their business grows, but it's just at the same time it's just too expensive to rebuild everything on the other cloud, so they never switch. Like sometimes it's just very painful. But in Web3 we have actually like in Web3 we have kind of solved the data access problem by putting a lot of stuff on chain, on blockchain. So we have like thousands of replicas of the same databases. So like potentially we can connect to any node and get the data and be free from vendor lock-in. But in fact, a lot of people basically, like because in particular case of blockchains and blockchain data, the data is organized on blockchain nodes in a very specific way that usually it's not very convenient for doing some queries or particular data extractions from it. So people create APIs on top of blockchain data, and these APIs are basically like some code sitting in traditional cloud, and it's centralized. So whenever you use that, API built on top of blockchain, then you also subject for this vendor lock-in. And there's a lot of like things. There was a story about Tornado Cash a couple of months ago. There are interesting stories about like if we have, even if we build DAOs that supposed to, automate the ownership and management of the Web3 applications, but our Web3 applications are only partly can be enforced. Their updates or their changes only partly can be enforced by DAO decisions because the applications themselves are not fully on chain. There are obvious limitations of the chain, so you cannot put like the application fully on chain. There is always some smart contracts on chain. There are always some backend sitting in the cloud in Amazon doing some indexing, API, user data, and stuff like that. And there are a lot of interesting stories like when the DAO makes a decision, you cannot really enforce the code sitting in Amazon to follow this decision of the DAO. So like if the DAO wants to update the off-chain application, that's actually not really possible to do directly. You need to bring someone who is admin of this Amazon account to go to log in and to roll out the update after the DAO made a decision. So you have this disconnection, which may lead to like really just the DAO, like managing applications by DAO just doesn't give you its real value in this case. Yeah, and again, so this is the point about like APIs that built on top of blockchain data. There are like many of them. There are NFTs APIs, like APIs for the wallets, DeFi APIs and stuff like that. And like if you build on it, you have again the same problem. You're subject of the lock-in, and the access can be disabled, even if these guys are cool and great and they're in Web3 community. They can change their mind, and you can, if you build on their API, you can lose your business. So there would be super cool if you can build like really decentralized APIs that really don't have centralized gateway to access them. So the way we see kind of how to solve it, like we need some sort of peer-to-peer decentralized computing that would be somewhere between centralized computing and on-chain computing that would also will have no middleman, no as blockchain, but will not have redundancy and like cost, like high cost, like on-chain computing. And it's basically like super useful for many use cases, like blockchain use cases, like general purpose Web3 use cases, like messaging, social network, whatever. It's like very friendly with the DAO. It has some, may have some even use cases that haven't existed before, like for example, like the Filecoin example with the ceiling computing job, which you want to probably run on decentralized infrastructure instead of centralized. So, and we approach this with Fluence, and the best way to think of Fluence is it's analogy of the cloud, but it's analogy not of the like all cloud services, but mainly analogy of serverless stack of the cloud. So basically, to enable this serverless stack, we build a development platform with all the tooling. We build a network where this development platform runs, and the network is the open marketplace of providers. Anyone can join anyone can run a node, anyone can be provider on this network and be part of development platform, and it's all kind of works together with the economic model. So development platform is basically I can skip it. So if you're familiar with the serverless stack, it's like cloud functions, workflows on top of functions, so like Amazon calls them step functions, and there are a lot of tooling that allow you to to have the scalability and performance of your application. And we kind of build the analogies of these tools. So we have the WebAssembly runtime, which allows to deploy and run WebAssembly pieces of code as a functions, basically. We built our own tooling for the distributed workflows that can orchestrate this execution of the functions. And we we try to enable all these simple pieces that allow you to build whatever backend business logic you want. And the workflow part is important because we are trying to, like, when you build the more or less complex backend, it always contains from some pieces. And if you want it to scale, you end up with this design that contains of two things. You have the piece of code to execute, and you have some business logic on top of several pieces of code and how they work together and what happens if something fails or you need to parallelize something and stuff like that. And usually in the cloud, you have this design. So you have a centralized API gateway where all the HTTP requests from the clients come, and then this gateway orchestrates the request to a bunch of microservices. And it all works perfectly, but the problem is someone needs to own and run this API gateway. And if you want to if you want to avoid this gateway, then we need something very different. So, and what we created is something that works very differently. So that's the basically protocol and the programming language that allows you to create and run any distributed workflows or network algorithms. Like this one, for example, this example, this is a few lines of code where I can say, I want to take the request from one user, and via some relay node, I will parallelize the execution of some function on several nodes, and then I will ask them to send the result of execution to like another node and calculate the average and send the result to the second user. And I don't have any coordination or like a gateway here where I need to, which keeps the list of nodes or which keeps the list of like the order of the execution. So this script is basically put into the data packet that initiated by the first user, and every node has the runtime that can parse this script and see, okay, I need to execute this part, and then I add the result to the data packet, and then I send it further. So basically, like, Fluence network consists of such nodes that contains the runtime of this Aqua language. They contains the WebAssembly runtime to execute functions. They may contain plugins with the data networks, like with storage networks, with like external. They can access external world, like via legacy HTTP calls. They can access blockchains and stuff like that. So basically, on any node, you can run a function that can take data somewhere, do some work, and put data somewhere else, or put data to the output request. And the experience of it, like it's very similar to the serverless stack. So you have functions, you can schedule them, you can call them, and they are event-driven, and you can run workflows on top of it. But in terms of pieces that required to achieve the proper developer experience that we used to in legacy cloud, a lot of things still kind of missing. So it's not yet at the moment where it's just magically automatically scales, all load balances or does stuff like that. But it's something that just we need to build as a part of the platform, and which will be built as a part of Aqua language as a like libraries of the language basically. Yeah, and again, like some basic features available already, some like data adapters available already, and a lot of things that looks more familiar on the level that you used to see in the cloud tooling is kind of still work in progress. But the cool thing is, like Aqua is basically a DSL that allows you to quite easily to create coordinator-free algorithms such as like failovers or balancing or like subnetworks, consensus, and stuff like that. So it's a very nice and developer tooling that is like targeted for creating distributed algorithms, so you can create whatever algorithms you run on the backend. And very important topic about secure model of all of this. And basically, like in blockchain, by default, you have security model of the consensus. So basically, like you have some computation, you deploy it to a network, and then every node has to repeat it, and every node has to get the same result. And that's why it's so expensive, that's why it's so slow, and stuff like that. So Fluence by default does not apply consensus on the computation. So like by default, it's basically trusted computation right now. So you deploy a function to the node, and then you trust that the node executed it correctly. There is a thing called trust graph that we have, which is something similar to the concept of web of trust. It means that if I know some authority and this authority trusts this node, then I maybe should trust this node because like it's like some other people saying it's trusted. But obviously that's not enough if you want to have like proper verifiable decentralized computations. And what we're allowed to do is to like it's optionality. So like if the consensus based computation is fine for you in terms of cost and performance, you can apply consensus to execution of some function, and you're going to have, basically several nodes saying, okay, the result of this function is this, so you can trust the result of the function. But more exciting thing that we are working on right now is the probabilistic and zero-knowledge proofs of the execution. And the goal here is that the Aqua going to have the proofs of the correctness of the workflow execution, and the Marine, the WebAssembly runtime, going to have the ZK proofs of the basically like WASM execution. So in the future, it's not now, but like in the future, you will be able to run to use Fluence the same way as the cloud. So you can run on just one node, and then you have all the proofs that this computation was executed correctly, and you can basically trust this, and it's much cheaper than when you use consensus because there is no redundancy. It depends a little bit on the ZK proofs generation, but there are ways to optimize this stuff. It's this area progresses pretty fast now. Yeah, so basically this development stack runs on the network, and the network is heterogeneous. Basically every node is different. Every node is a hosting provider, and every node runs different functions wherever it allows to run on their hardware. And yeah, so if you have such a network, if you have such development stack, we can really build applications and APIs that can be not really can have similar capabilities like applications on chain, where you have this separation between author of the application who creates smart contract and the network that runs the application. It's like if for example I have the basically blockchain have this feature of forking, right? If some part of network disagrees with update that developers pushes, the network forks. And here you can have such sort of application forks. Like if I run some application on some nodes in the Fluence network, and then I want to, create the update and deploy the update that the users don't like, the users can say, okay, like we are forking the application, we keep running the older version on the nodes that it was available before, and the new version maybe will also be adopted by some other nodes. But that creates a lot of flexibility. So in terms of like, if there is a version of some application that has demand, the user demand for it, it will exist while it has demand. So like, while some people are ready to pay to nodes for hosting this version of an application, regardless what the original author of this application thinks or does, this version may exist and may be available for users. And this is some state of things. So we have the network up and running right now, and you can do some basic stuff with that. We want to have the DAO, make the network to be governed by the DAO. Should come this year, but with this market, we kind of not sure yet. And we work a lot on all of these incentives and the economic model and the proofs, because like it's all connected. Like the proofs of computations is tied to reward for the computation, because we want only pay to those nodes who executed the code correctly, and that's why we need the proof of computation for enabling the payments on the network. We don't want to rely on just reputation. So like the economics is very interesting topic, because you can not only just have the payments for computation, you can play with this a lot of on-chain primitives to like enable even some sort of DeFi on top of computation workloads and stuff like that. And there are several other interesting things here that can be enabled. For example, the whole thing runs like a decentralized open cloud where there are compute providers, there are some application developers, and there is some, the economics of it exists on chain, so it's kind of transparent. You can see which applications, how much money pay to which compute providers, and which pieces these applications consist of. And this allows us to enable one very interesting thing. So in current clouds in Amazon, like for example, there are databases, like open source databases, which being used by millions of developers. And the authors of these databases do not really get any money from Amazon from the revenue they generate on their creations. And this is kind of the big problem, because it's disincentivizes to build open source, because like if your open source is popular, the cloud's gonna adopt it and they're gonna extract all the money they can, and they are not really incentivized to pay you anything back. And here we can enable, like, because we have this link between where revenue goes and which pieces of applications generate revenue for the nodes, we can extract the small part of this revenue stream and send it to the authors of this useful pieces of applications, such as database or like maybe like libraries, stuff like that. They've been reused across different applications, and you as an open source developer can like really continue building the open source product and get a fraction of cloud revenue, which is super cool. So this is just a link to some network dashboard. Like it's still kind of, you can call it testnet. So it's still kind of work in progress, but it shows something that happens on the network. And that's it. So basically, there are some communities that we have, and obviously we are hiring. So if anyone interested, feel free to reach us out. That's it.